Good afternoon, and thank you for joining us for the College of Continuing Education webinar, Managing the U.S. Bank Stadium Project. My name is Elena Gallagher, and I will be your moderator for today's event. If you have any questions about this webinar or other programs we offer, please feel free to contact a learner representative in the Information Center. Contact information for the Information Center can be found on the last slide. There are a couple of logistical points I would like to address before we begin. You can feel free to submit questions at any time during the webinar. The questions you submit will be addressed in the last 10 minutes of the presentation. To submit your questions, click the Q&A button in the top right-hand corner of the screen, then type your question in the box below and click Send. We will be sending out an email in the next few days with a link to the recording of this webinar. The link will be sent to the email address you submitted during your registration. In today's presentation, the Senior Project Manager for Mortenson Construction will be joining us to discuss the long and involved process of constructing the new Minnesota Vikings Stadium. The topics that will be covered address everything from the background of the U.S. Bank Stadium project to the negotiation with stakeholders and addressing their special interests. I'd like to introduce today's speaker, Brendan Moore. Brendan is the Senior Project Manager for Mortenson Construction and has been leading the U.S. Bank Stadium project. He earned his bachelor's degree in civil engineering from the University of Maine and his master's from the University of Minnesota. Brendan has been with Mortenson for more than 10 years and has worked with numerous sports-related projects, including Target Field's Pegula Ice Arena located at Penn State, and of course, the U.S. Bank Stadium. Without further ado, I give you Brendan Moore.
Thank you, Elena. So just a little bit of an overview of what I'm going to be discussing today. I'll start out talking a little bit about the background of Mortenson, move on to the stadium introduction, talk about a little bit of the statistics about U.S. Bank Stadium. I'll move on to touch upon how Mortenson has managed the buyout, procurement, and construction planning. Talk about how we manage our schedule using a CPM schedule and Primavera P6 software. At that point, we'll get into kind of the meat of the presentation, really looking at construction progress photos and talking about how we've actually built the job. And then I'll finish up the presentation looking at the two most iconic aspects of the stadium itself, the ETFE roof system and the operable doors. So with that, a little history about Mortenson. Mortenson's a family-owned business that was started in 1954. It's grown considerably over the past 62 years and now manages the development and construction of everything from massive wind and solar projects to major metropolitan sports stadiums throughout the country from coast to coast. This slide truly says it all. It's all about our relationships, just like any other aspect of business. And we see those important relationships as our relationships with our customers, our owners, architects, engineers, subcontractors, our trade partners, really allow us to be able to deliver these important civic projects on time, on budget. And we truly couldn't do it without those trusted relationships. We also have 10 regional offices throughout the United States, as you can see on the slide here, as well as multiple national groups that travel around on a daily and monthly basis and work throughout the United States and Canada. The sports groups being one of those. So, over the past 30 years, we've had the pleasure of building many of the premier sports and entertainment venues in Minnesota, 4 of which you can see on the screen here. Target Field, TCF Bank Stadium, which were completed in 2010 and 2009, as well as Xcel Energy Center and Target Center dating back to the 90s. So in addition to the local sports marketplace, we also have a major presence in the national sports market. We've completed projects throughout the United States in Louisville, Kentucky, Denver, Colorado, the FedEx Forum in Memphis, Tennessee for the Grizzlies, as well as the Sprint Center in Kansas City, Missouri. And in addition to the professional sports market place, we do a lot of work in the collegiate sports market as well. And 2 of the most recent projects we've completed, Pinnacle Bank Arena at the University of Nebraska, as well as Elena mentioned earlier, Pegula Ice Arena at Penn State University. All right, so let's get into learning about U.S. Bank Stadium. As many of you are fully aware, it's going to be home to the Minnesota Vikings. The current project construction budget is approximately $860 million. It's used to construct just under 1.8 million square feet. We mobilized and started on site in December 3rd, or on December 3rd of 2013, and our substantial completion date is July 29th, 2016, short 5 months from now. The stadium has approximately 65,000 seats. Included in that 65,000 is approximately 8,000 club level seats, as well as 131 premium suites. One of the iconic aspects of the building that I mentioned earlier, it has the largest ETFE roof in North America, which is essentially the translucent roof on the south side of the building, which we'll get into much more detail on later on in the presentation. So in addition to being home of the Vikings, US Bank Stadium is also a venue for numerous civic, community, athletic, and other cultural activities, which we'll look at right now. So the stadium can be configured in multiple configurations to support whatever event is happening at the time. You're looking at football configuration here that'll be used for obviously all regular season Vikings games, as well as for the 2018 Super Bowl. There's also a baseball configuration, and the baseball configuration is truly an example of the Minnesota Sports Facilities Authority, the MSFA, and the Vikings team working together to develop a solution that doesn't take anything away from the football layout, but also allows the stadium to be used for many other events throughout the off football season, baseball being one of them. Now, one thing I want to point out in this slide, on the left-hand portion of the slide, or of the side, you see the seating that was, if we look back at the football layout, there's seating on the entire north side of the field. Looking at the baseball layout, all that seating has been retracted back. There's the largest section of retractable seating in the world that's being installed at US Bank Stadium, and the 34 rows by about 400 feet long all retract back to allow the outfield for the baseball configuration. The stadium can also be configured to host basketball events. Many of you are probably aware that US Bank Stadium was selected for the 2019 Final Four, which was a big win for the ownership and the community in general. There's also a soccer configuration that will serve as an alternative to the new outdoor MLS stadium in St. Paul. In addition to sports, there is also motocross, concert configurations that will really work to maximize the events per year that US Bank Stadium can host. So understandably, everyone always wants to discuss, how does US Bank Stadium compare to the Metrodome? So let's review the numbers. In the lower right portion of this slide, you can see the outlined in red here is the former footprint of the Metrodome. The blue outline is the footprint of the new stadium, so it's significantly larger. This is kind of an overlay of placing the old size of the Metrodome, the 3D model of the Metrodome, inside the new US Bank Stadium. There's many differences from a kind of statistics standpoint. As I mentioned, US Bank has 65,400 seats, which is actually expandable to 72,000 for the Super Bowl, compared to the Metrodome, which was about 64,000 seats. US Bank has approximately 1.8 million square feet, just under 1.8 compared to the Metrodome, which was about half that size at 900,000 square feet. There's 7 new club premium lounges in the new building compared to 1 club lounge at the Metrodome. There's 8,000 club seats compared to 240 club seats at the Metrodome. As I mentioned earlier, there's 131 premium suites available compared to 87 at the Metrodome. And perhaps one of the most staggering characteristics, there's over 12,000 square feet of video board compared to about 650 square feet of video board at the Metrodome. From a standpoint of TVs and just the visuals walking around the new stadium, there's going to be over 2,000 TVs compared to 280 at the Metrodome. And from a vertical transportation standpoint, the Metrodome had 3 elevators. US Bank Stadium has 16 elevators. Escalator-wise, the Metrodome didn't have any escalators, and US Bank Stadium has 32. So many large differences that should really make a big difference to the fan experience. All right, so moving on to talk about how Mortenson bought out, how we procured and planned the construction. Really, one of the biggest aspects of making sure that we're buying out the right package from our subcontractors is going back to the documents. How well are your documents developed at the time that you need to buy out certain scopes of work. And one thing I want you to keep an eye on over the next 2 or 3 slides is keep an eye on which document package. You can see I have listed in these 2 slides, or these 2 scopes of work, the 50% design development documents, which for those of you who are involved in the construction industry and the design aspects of these large facilities, you know that a set of 50% design development documents necessarily doesn't have a lot of detail. It doesn't have near the amount of detail that you would normally expect to have when you're going to sit down with a subcontractor and go through and purchase a defined scope of work. But the way that these sports projects are typically scheduled is that there just is not the time available to fully develop, spend 1.5 years or 2 years for an architect and a design team to fully develop a complete set of documents, and then take that set of documents and the contractor go out and bid that scope of work. It just the time, the amount of time that's available for these jobs is always compressed compared to a typical construction project. And as you would expect, owners are always interested in building it as quickly as possible so they can get going and move into their building and start generating revenue. So early on, the first couple of procurement packages that we put out on the street, we had outreach events, just trying to drum up as much interest from the local subcontractor community and reaching out to subcontractors around the country as well, just because of the sheer size of this project. So the long span roof steel is one example of a scope of work that we couldn't necessarily wait to get further down the road with the design documents just because of the long lead nature of the steel. US Bank Stadium roof has a unique grade of steel. It's a grade 65 steel compared to a typical grade 50 or a grade 36. Which allows those steel members to span longer distances without necessarily increasing the size of the members. So that steel came out of Luxembourg, so we had to make sure that we were leaving enough time, which it was about 8 or 9 months, prior to having the steel on site that we needed to place that mill order. So it's all about identifying what your longest lead items are, and then working your schedule from there. ETFE, the fabric roof that I'll get into in more detail later, that was also a scope that we wanted to procure as early as possible. We hadn't worked with this material before. It's kind of one of the newest design elements of a lot of sports facilities throughout the country, and so we also bought that out very early. From a MEP standpoint, mechanical, electrical, and plumbing, we wanted to make sure that we got our mechanical, electrical, plumbing subcontractors on board as quickly as possible as well. I'll go through these other procurement packages. Again, procurement package 3 included our earthworks, drilled foundations, our stadia, a lot of our enclosure, as well as your waterproofing, an early mist metals package. Those are all elements that we felt that we needed to get going, to buy out, and to start planning early on. So we continued to work off design development documents at that point. Procurement packages 4, 5, and 6, still working off basically not construction documents. And it wasn't until bid package 6 and beyond that we actually got into to really diving into the 100% CDs as issued by the design team. Lastly, to finish up the procurement discussion, there's always some items that are bought out by the ownership. Sometimes they have relationships in the industry, so they want to procure specific scopes of the work. Scoreboards was one of them for the MSFA and the Vikings. They bought that out through Daktronics. FF&E is typically procured by ownership as well. And kind of the newest component of these large sports facilities are the distributed antenna system, or the DAS system, just making sure that everyone has wireless capability, or as much as they need. You know, so when 60,000 fans get into the building, that everyone's phone still works. Okay, moving on from procurement, when we, you know, Mortenson typically, you know, during the planning phases, we will develop a 3D model of the job site and come up with a site logistics plan, which is typical for you know, for these large construction projects. And really, from a site logistics standpoint, it's all about managing your space on site and making sure that the materials can flow in and flow out of the job without any issues. So, you know, on this slide you're looking at here, north is to the top of the slide, we identified early on that we were going to utilize the northeast corner of the job site to bring material in and out of the main bowl area, which you'll see in a few slides, you know, how crucial that became to managing our space on site and really the steel fit up and steel erection activities. We also, you know, the Metrodome was located on the west portion of this site. We started our concrete operation on the east and really built our whole schedule out of the east side of the job so we could start as early as possible while the Metrodome was still in place. And it happened to work out well that the loading dock, the permanent loading dock for the building, also came out of this northeast corner. So we actually pulled the construction of that loading dock for, you know, up in the schedule so we could utilize it for the balance of the project. Okay, so in addition to just planning site logistics at a high level, we also plan our daily activities at a 6 a.m. meeting every single day with the superintendents and many of the job foremen on site, just to talk about coordination, what cranes are going where, who's swinging in what direction, what work needs to happen on each level of the building. And again, this is looking basically looking west. You can see that, you know, we had multiple gates. This is along 11th Avenue, 3 gates there to shuffle material in and out. There's a gate off the southeast corner, you know, another gate off the southwest, as well as our main loading dock that came into the northeast corner. All right, so, you know, one other tool that we use is called Virtual Design and Construction, VDC, to better plan the execution of our work. And really, you know, VDC technology allows us to build faster, smarter, and leaner than we ever have in the past. And this is just a fly-through of what we were able to create with VDC technology to give the ownership a preview of really what their locker room is going to look like. You know, in these sports facilities, the locker rooms and some of the club spaces are often, you know, one of the most talked about and debated rooms throughout the building. So, you know, using these types of tools gives us, you know, a perfect opportunity to show the ownership group and frankly the head coaches and the players, and, you know, we can get feedback from multiple sources and not have to be walking those individuals through the spaces after they are built. All right. So, you know, typically these large sports projects are historically notorious for being behind schedule. There's all kinds of horror stories out in the industry for you know, jobs having 50 to 60,000 item punch lists, finishing 6 to 8 months behind schedule. And Mortenson is truly committed to making sure that we don't have jobs that are delivered in that way. We just don't believe that it's good customer service. So, you know, we use a Primavera P6 scheduling software to develop and manage our critical path schedule. I'll call it, you'll hear me refer to it as the CPM schedule for all our projects. And we truly use that to ensure that we deliver our projects either ahead or at a minimum on schedule. And really that, you know, a CPM schedule is the tool that you have. It's truly your roadmap for how you're going to complete the job on time. There's too many activities that go into a construction project of this magnitude to according to us at least, manage it any other way. Our superintendent, Dave Mansell, is a fanatic about managing, his projects to a CPM schedule. And, the use of that schedule is critical to identifying, where you're having your schedule issues, what is truly your critical path for, if an activity doesn't finish on time, whether that's going to or has a potential to actually delay the project as a whole. Currently, we have over 25,000 separate activities in the U.S. Bank Stadium CPM schedule. And, people often ask, it's one of the top questions we get on tours or from the media is, are you on schedule? Well, we're always able to say, yes, we're on schedule, and that's always the truth. But that's not because there hasn't been lots of issues come up in the field that we've needed to overcome. It's just about being able to understand, fragment your schedule for those impactful activities, and being able to assess what you need to do to overcome those challenges. So this slide shows is just an example of one activity, one enclosure activity out of our CPM schedule. And as you would imagine, each activity has a start date, a finish date, a duration in between, and then it's integrated with logic into the balance of the schedule. You see in the lower left corner, there's a list of the predecessors, the activities that have to be done before our specific metal panel activity needs to start, and then there's a list of successors on the bottom right. And those are all activities that can't necessarily start or finish before the activity we're looking at can finish. And we correlate that, the metal panel North Elevation 5 activity to an actual key map. So this is just one example of, with the enclosure, how we generated a map, split the building into different areas by separate grid lines, and then we use that to track that activity in the CPM schedule. This is another example of what we did with the roof steel. We came up with a very detailed erection sequence map like you're seeing here. And actually, we created a separate erection, bolt up, and steel detailing activity for every single steel sequence on the project, which is, a lot of people would hear that and say, it's unnecessary. We don't, based on our experience building these buildings, we think it's absolutely necessary. Okay, so enough about construction planning and theory. Let's talk about actual construction. So the Vikings played the last game in the Metrodome on December 29, 2013, defeating the Detroit Lions 14-13. It was a short 3 weeks later that the dome inflation units were turned off, truly commencing the demolition of the Metrodome. We bought out all the site work, earthwork, and demolition through Ames Construction, who also involved Fralone to help them complete the demolition of the dome. On February 23rd, it was a Sunday morning, we demolished what we called the upper ring beam of the Metrodome. I'll play this a few times so everyone can get it. Make sure you can see as much as you want of it. But as we got into the demo, we came to realize that it was truly a safer option to implode at least part of the building compared to just kind of picking at it with construction equipment that you're limited by how far away you can be when you're trying to use certain pieces of equipment. Even some of the largest equipment in the industry presents a significant safety hazard. So because of the downtown setting of the Metrodome, initially we thought, well, maybe we could avoid having to implode part of it. But like I said, the more we got into it, we came to realize that this was truly the safest option, and things went very well. Okay, so with the demolition of the Metrodome, that enabled us to continue excavating approximately 900,000 cubic yards of material out of the site, and really clear the way for our concrete operation. All that material, for those of you who are familiar with the southwest part of the Twin Cities, a lot of that material ended up at the interchange of Highway 169 and Highway 69. So that was going on during the early phases of U.S. Bank Stadium as well. As far as our structural concrete operation, it started in January of 2014, continued through mid to the end of June of 2015. There were over 12,000 tons of rebar on the project. That was equal to the approximate tonnage of the roof steel. We poured over 100,000 cubic yards of concrete, some of which you see in the photos here. This is the east buttress. So at each end of the main ridge truss, there's what we call the buttress column that basically accepted the entire load of the main ridge truss, about 990 feet long, and took that load down into the bedrock. And what you see here basically transfers all that load about 40 more feet down into the ground. We actually had to use a 30-ton chiller just to cool, or to be able to thermally control the concrete as it cured out on this massive column. Just another photo of the completed east buttress column, and then basically this whole setup was mirrored at the west end of the project as well. The majority of the concrete structure at US Bank Stadium was constructed using pan and joist decks. There were over 110 separate deck pours, and for those of you who work in this industry, we had 8 different leading edges of our pan and joist decks happening at one time at its peak, and that's a lot for both Mortenson and our subcontractors to manage all at one time, but it was truly something that we needed to be able to accomplish, to basically finish the job in the time frame that we needed to. And really, it's all about getting your structure up in place so you can control the balance of the pace of the project. And by having that many leading edges at one time, it allowed us to do that. This is a picture of the loading dock that I referred to earlier in the northeast corner of the project. On the right-hand side of the screen, you see this. It looks fairly small in this picture. It's not nearly that small when you're standing there, but nonetheless, all the material that you'll see in the middle of the bowl area in the next few slides came in and exited through that tunnel. Okay, so structural concrete. Kind of looking at the numbers. This is a flyer that we distributed during our concrete topping out party in June of 2015. There were over 10,000 concrete truck deliveries, over 2,000 concrete pours, like I mentioned, well over 100,000 cubic yards of concrete. And it wasn't all just foundation and decks. There was a ring beam that surrounds about 80% of the upper roof that ended up being poured at about 290 feet above the grade level, which is a substantial effort to get concrete up to that height. All right, so once enough of the concrete structure was underway, we started progressing in July of 2014 the structural steel. And the US Bank Stadium is unique in the sense that on a lot of projects you'll leave out or a lot of sports projects you'll leave out a section of the arena or the stadium, walk the crane out that leave out space, and then complete that section later. But the unique geometry of US Bank Stadium and that the skewed aspect of the main ridge truss and how some of the secondary trusses tie into it didn't allow us to kind of build one end and work our way out. So we actually were progressing the steel from both the east side and the west side at the same time. And there were some massive sections of the main ridge truss that needed to be pre-assembled in the bowl area and erected, which required us to have a very substantial crane to accomplish that. So what you're seeing here, a lot of you probably saw it on the news at the time that it was delivered and erected. It's a DMAG crane. It was delivered on approximately 70 flatbed semi-trucks to the stadium. It's one of the 3rd largest cranes in the world. It has 1.2 million pounds of counterweight, and there's actually a carriage further off the back, which you can't see in this photo, that allows another 250,000 pounds of counterweight. Our largest pick on the job was approximately 720,000 pounds. Here's just another picture of the DMAG booming up. Depending on the wind, it had a wind limit of approximately 30 miles per hour. So we would end up having to, we called it knuckle down, and basically set the tip on the ground in the bowl on days or nights when we would anticipate wind gusts over 30 miles per hour. But you can see in the bowl in this photo the sections of both the west ridge truss column as well as portions of the east here on the lower left being pre-assembled in the bowl. And you know, the ridge truss itself, in its deepest spot, it's about 60 feet deep. So you know, these truss sections are so massive that there's no way you could you know, assemble it in a shop, put it on the back of a truck, and send it down the road, deliver it to the project. So we essentially had to deliver everything in pieces and use the bowl area to pre-assemble those sections of ridge truss as well as the Queens Post trusses, which I'll talk more about shortly. Fast forward a few more months to November of 2014. Gives you a little better appreciation for, you know, all the work that's happening all at one time. You can still see around the perimeter all of our concrete operation in full swing. But there's also all these structural steel activities that are being progressed both from the west side, which my cursor is on now, and the east side. And you know, all the green shoring towers you see, those are all temporary shoring towers. We had 11 of them on the project, and they are basically there to support the roof structure prior to it being able to you know, be fully connected together and support itself. There were lots of jokes on the project that, you know, with all our yellow tower cranes, which you can see here, and the green shoring towers, that we were somehow secretly supporting the Packers, but that was not the case. Fast forward another month, just one of our picks of the east section of our main ridge truss. You know, this was one of the largest picks. This is our 720,000 pound pick. You can see the counterweights I talked about earlier. This carriage that I mentioned is in the bottom left portion of this slide as well. It's difficult to show in pictures the sheer magnitude of how massive both that crane and of the steel is itself. The largest wide flange steel shape on the job is a W36 by 854, which for those of you who aren't in the industry, the 854 means how many pounds per lineal foot of that beam. And if you do the math, that's about 18 pounds for a quarter-inch cross section of that beam. So if you slice that cross section into a quarter-inch thick piece, it would weigh 18 pounds. All right, fast forwarding another 4 or 5 months it takes us to May of 2015. You can still see some of our green shoring towers, but we're obviously continuing to progress the ridge truss steel erection. We're getting very close to being able to connect the two pieces. And in June of 2015, we actually made the connection. The majority of the ridge truss was built up in sections, like you saw a couple slides ago. But the last two pieces, the connecting pieces at least, we put in as sticks right in the middle. And you know, there was certainly even though, you know, all the planning and all the intermediate surveying that happens, you know, with the erection of each piece, that's all telling you that it all lines up. There's still a sigh of relief that you breathe when it all connects together. And you know, Lejeune Steel fabricated all the roof steel. Danny's construction company out of Shakopee was the steel erector, and they both did a fantastic job. Okay, so similar flyer for the structural steel by the numbers. Just in the roof steel itself, there was just under 22.7 million pounds, and about 11 tons of steel just in the roof itself. What we considered our non-long span steel, or was is the balance of the skin steel for the building. There was about another 8,000 pounds. So it brought the total tonnage for the steel tonnage for the project to about 19,000 pounds. The ridge truss itself, as I mentioned a few minutes ago, it's approximately 989 feet long. For those engineers out there, you know, they'll expand and contract over 7 inches. Depending on what time of year it is. All right, so moving into one of the most iconic elements of the building that I mentioned a few minutes ago is the ETFE roof system. And really, what is ETFE? Why was it used on this project? Why is it gaining some momentum on the design side of a lot of these buildings? It's used because of its translucent nature. It provides an open air feel to a space without having to expose the inhabitants of that space to the climate outside, which is an important thing for Minnesota, especially during at least half of the football season. The material, it's a lightweight, it's flexible, it's durable, highly tensile strength material. It's been used throughout Europe, parts of Australia, parts of Asia for quite some time. For those of you who remember the Olympic Stadium in Sochi, as well as the Beijing Water Cube, those were all constructed or integrated ETFE into the design and construction. U.S. Bank Stadium is unique. There are 75 total cushions, and the largest of those cushions is approximately 10 feet wide by 300 feet long, which is the largest cushions that our subcontractor Vector Foil Tech out in Bremen, Germany, had ever constructed or put in place. The ETFE itself, I'll get to a cross section in a moment, but each section, or we call them pillows, are inflated using 4 air handling units that were placed up on basically an inside of the ridge truss that runs the full length of the building. There's also a dot or a frit pattern on the outer layer of the ETFE that reduces the solar heating effect on the building. So it still allows light to penetrate, but it was able to direct a lot of the UV rays out. All right, this is a cross section just from the documents of ETFE. What a typical cushion would look like. As I mentioned, the top green section, that's the outer layer of the ETFE. That the dot pattern, the fritting, is printed on the interior side of that outer layer. And there's a middle layer that's used to create 2 separate chambers of air, and then obviously the bottom layer to complete the oculus. And each one of these chambers is then has air circulated throughout for basically the life of the building. It's not a high pressure system. It's inflated to about 5 psf. As I mentioned, there's 4 main inflation units. They have redundant motors in them. So certainly, if one of the units goes down, the whole roof doesn't start to sag and collapse. It's truly a very redundant system. And this slide just shows how the ETFE interfaces with the roof steel. On the left-hand side, you can see a typical upstand, what we call an upstand, that basically attaches right to the top of our roof purlins, and goes up to accept the ETFE extrusion. And the pillows, the flexible portion of the ETFE roof, just clamps into the side of the extrusions. The ETFE was installed using a fairly unique work platform netting system. Vector Foil Tech came to us and proposed, with an engineered plan of how they intended to safely install this roofing system, and they've had a lot of success using a netting system like you see here in blue on other projects throughout the world. And the more we learned about it, we liked it. It allows them to really put that netting system in place and then install all of their accessories, fully bolt down all of their extrusions that are sitting on the upstands, which I'm running the cursor over right now. And really, they use that as a working surface the entire time up until the point that they're going to start pulling the cushions down from the top of the roof. This is a photo of how they used basically 10 or 12 people to basically stage the cushion at the top side of the roof, and then just work their way slowly down the roof as they kind of pull the cushion along. And even with this work platform netting, they were fully tied off the entire time they were working on the roof. This photo is just a picture of the final inflated cushions. As I mentioned, there's 75 total cushions on the project, and as far as a sequence, I want to jump back to our main slide here. We basically needed to follow the erection of the roof steel with the ETFE. And one of the kind of critical milestones in our schedule was getting the ETFE installed and completed by November of 2015 to allow the balance of the interior finishes to progress. It would have been very difficult for us to make a completion date of July of 2016 without having the building fully enclosed by, basically by the winter, by November, December of 2015. Okay, so that gets us to the last kind of iconic element of US Bank Stadium, which is the operable doors. I'm sure some of you have seen some news reports about the operable doors recently. We were opening and closing a couple of them to facilitate some of the construction work that goes on around the doors a week or two ago, and it got a lot of attention. So there's 5 large operable doors on the project. I'm running my cursor over the northernmost door, door 1, 2, 3, 4, and 5. And basically the shortest door has a jam height of 75 feet, and then there's a sloping head condition up to the tallest door at about 95 feet. There's, as I mentioned, there's 5 operable doors. The dimensions vary in height, as I just went over. Each door is the same width. They're all 55 feet wide for a total width of 275 feet. The heaviest door is approximately 100 tons, and all that 100 tons is basically pivoted around a 3-foot diameter steel and concrete column, which I'll show you in more detail shortly. The doors are controlled. They're opened and closed by 6 hydraulic rams. They're basically 3 different pairs that work in tandem to push and pull, open and close each door. Each door has an opening and closing time of 5 to 7 minutes. And the doors were fully manufactured by industrial door contractors out of Columbia, Tennessee. Now, when throughout the industrial door contractors, or IDC, was integrally involved in helping us develop the design. Throughout the design process, we worked on these doors for approximately 2 years. And working hand in hand with HKS and Thornton Tomasetti. This fly-through that I'm showing now just gives you an idea of how the doors function. These horizontal, we call them wing trusses. There are 49 wing trusses throughout the doors, and they're basically hung off of these. We'll get to it in a moment here. These 3-foot diameter columns, and so the wing member trusses tie into what we call the Tri-Chord truss, which then attaches to the 3-foot diameter column at the top and the bottom. And there's 2 bearings with each of these doors. There's a bearing at the base, which basically receives the entire load of the door, and then there's also a bearing at the top. As you can see, these hydraulic rams function in tandem, like I mentioned, and just push and pull to open and close the doors. The columns had to be so rigid that with the eventual design of the doors required glass to be applied to the outside of the structure, and so the doors needed to be rigid and stiff enough so that as we were installing the glass, that the steel didn't start to sag and essentially crack the glass that we had just installed. So there were many components to the 3-foot diameter columns that were beefed up, made as rigid as possible. One of them being the nodes you see here in the upper right portion of the slide. There's 23 node locations where the typical 3-foot diameter column had a steel casing of about a ½ inch. At those 23 node locations where essentially where they tied back to the building, which I'm showing in red on the left-hand side of the screen, there was a 3-inch walled section of steel. And there's also a considerable amount of steel reinforcement inside at those locations as well. So just trying to make those steel columns as rigid as possible. You can also see on the picture in the lower right how the rebar that eventually had to get threaded through all that steel inside these nodes was threaded through all that steel in the shop condition. We also had to use a steel cabling system. There was a set of counterweights and steel cables that were attached to to these trusses. Let me jump back to the doors here. So there were counterweights, and they were attached to these our horizontal wing member trusses to basically take all the camber out of those steel members. And for those of you who aren't involved in construction, camber is basically a curvature that's built into a horizontal steel member to basically make sure that once the member gets erected, that it's not sagging under its own weight. So if you build camber, if you build kind of an upward curvature into that member, when that camber comes out and the member deflects, it's meant to deflect to a horizontal condition. So we ended up taking the camber out of these horizontal members, utilizing a counterweight system and cables prior to installing the glass, and then we strategically removed those cables as we progress the glass installation. These are just a couple of photos of the shop fabrication of the Tri-Chord trusses. In the red circle on the left-hand side of the screen, you see where that 36-inch diameter column would eventually end up resting. Here's a photo of some of the horizontal wing member trusses. Basically, the outside of the door in the bottom photo is facing the ground, and these trusses were much too large to be shipped down the road as a system. So we delivered each of the trusses to the job on I think we fit 5 on a truck, 4 on a truck, and then assembled them, erected them in place on site. Lastly, there's just a couple more photos of basically what I was showing in the fly-through of the operable doors compared to what we actually built on site, which is on the right-hand side. And again, the doors are controlled with hydraulics. There's a single hydraulic pump unit located on one of the upper levels of the stadium, just to the south side of the doors, that pumps the hydraulic fluid out from that unit to service all these different hydraulic rams. All right, and with that, I will take any questions.
Wonderful. Well, thank you, Brendan. That was incredibly informative, and we are all very excited to see the final project. A couple of questions have come in. I will just say we might not have time to cover all of the questions during this session, so I apologize for people who did ask questions and we don't have the opportunity to respond to those. The very first question we have, how do you manage risk, cost, schedule variance on a 50% design estimate?
That's a good question. To say how we manage risk, I mean, managing risk is all about identifying what your risks are, because it's a tricky situation between identifying what you think the risks are versus what else is actually out there. I would say, our experience managing sports projects in the past gives us a pretty good idea of what we see as the risks are. Each job, carries its own special set of, or kind of unique set of risks. But I would say, going back to the documents, it's all about communication and making sure that as we were procuring work and writing contracts based on 50% DD documents, that we were flushing out, essentially making sure that we were we were completing the rest of the documents and making sure that the scopes of work that we were directing our subcontractors to price and to review and get their feedback on were based on a complete scope of work. And the subcontracting community in the Twin Cities and really greater Minnesota, the whole upper Midwest are some of the best subcontractors throughout the country. And in utilizing, kind of leveraging some of those partnerships, we were able to in our minds hedge as much of that risk as possible.
Wonderful. Well, thank you for that. The next question, who did site civil and when was that procured? Ames
Construction was awarded the site civil package. It was bought out as part of bid package 3, which would have been in November, December of 2014. I mean, the landscaping package all came later. That was significantly later in the project.
Great, thank you. So how did you, as the senior project manager, receive and monitor progress and updates?
As far as construction progress updates, I'm one of a large team of people who work on this project for Mortenson, and we have a very skilled set of superintendents that truly do a fantastic job of monitoring the work progress, reporting. Reporting the work progress outside, and really, I talked about the 25,000 activity CPM schedule earlier. That sounds like a tremendous effort to develop. It's also a tremendous effort to maintain that and be feeding. It's just like anything else. You put a lot of effort, put good information into it, you'll be able to get information back out of it. So it really comes down to your schedule.
Perfect, thank you. How are issues reported on when they arose? Can you touch on an issue and how you managed closure?
Well, I mean, why don't we talk about one of the issues that's been in the news? So, I mean, the leaks up at the snow gutter elevation of the building. That's a perfect example of how an issue that came up in the field. We had identified a few locations that were leaking. Performed a significant investigative phase to try and just ascertain what was going on. But the beauty of having a well-developed CPM schedule and being able to progress our enclosure, so it was fairly almost complete by the end of 2015, allows us the benefit of being able to address items later. So going back to some of those other kind of schedule nightmares that I talked about earlier. If you're not finishing your enclosure until a month or two before you need to finish the project, you don't have time to react to issues that come up. And there's always going to be issues that come up. For anybody who works in this industry, it's just about trying to identify what could potentially come up, because you always know there's going to be another 25% of things that you don't anticipate. So that's always the challenge. But as long as you're leaving yourself some room, some time to deal with it, you can overcome truly any issue that comes up.
Awesome, and that was a perfect example. Thank you. So how many support PMs did you have working with you, and how did you manage the distribution of work?
Well, I talk about the project as a whole. I mean, Mortenson, we set up our management staff to basically have two senior level executives, and then each kind of broad scope of work, basically the enclosure, the structure, mechanical MEP, mechanical, electrical, plumbing, and interiors, some site civil and landscape foundations. Those were all separate kind of columns of work, and the way that we basically assigned responsibilities were to have a senior project manager oversee each one of those major scopes of work, and there's always kind of bleed over and things that you get more involved in depending on your workload and frankly your interest to take on more. So Mortenson does a great job of giving individuals more responsibility if they're interested in having it. So
great, thank you. Now this one's a little bit more personal, but what was the biggest lesson you learned to date as a project manager as a result of this project?
I would say you really need to trust your intuition, and even though people often look at this project and say, holy smoke, it's such an incredible project. There's so much that goes into it. Where do you start? I mean, you bite off small pieces just like any other project. It's kind of the same old adage. The long journey starts with the first step, and that's truly how you just need to think of it, and you need to just chug away at it, and really the team of people that you work with, just like you'd expect, makes a huge difference. And we've had a fantastic team working on this job.
Excellent. Well, thank you. And thank you again, Brendan, for the excellent presentation. We all really enjoyed that. And as I stated at the beginning of the webinar, we will be sending out an email with a link to the presentation soon. Another thing to look forward to are some upcoming courses that can further supplement what you learned today. The courses you see on the slide are just a few upcoming courses we offer. Visit our website for a full list of courses and educational programs. We hope you enjoyed today's webinar as much as we did. Thank you, and have a wonderful day. Also, go Vikings.